Hey everybody, we are going to try to do a LeetCode problem live today. Uh, I'm going to pick something with medium difficulty. Actually, let's pick something easy difficulty level today. We have only done one easy problem so far. We did palindrome number last time. Let's pick merge to sorted lists. It looks like a pretty straightforward but interesting one. Will help you practice merge logic in any two lists. Okay, so let's read the problem. Should be a standard problem, but just to make sure, you're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay, this makes sense. I think very standard. The main thing to note are we should be splicing together the existing nodes in the first two lists or in the two given lists instead of allocating new nodes and copying them. And that's what makes the problem actually more interesting. And I think returning the head of the merged linked list also makes sense because the head could be either the node from list 1 or the head of list 1 or the head of list 2 based on the value. Let's see if there are any constraints. Yeah, the number of nodes in both lists in the range 0 to 50. Not sure if that constraint is actually helpful to simplify code. I don't think so. Same with this. The values are between -100 and 100 inclusive. Not really helpful to simplify code. The code should work even beyond that. And both list 1 and list 2 are sorted in non-decreasing order. Makes sense. That's a constraint and looks like we don't really have to do error check. That's actually true. Okay, with that, let's jump right in. Okay, so looks like they have given in comment the node class, which they will use in the template code they have when we run the whole code. So we don't have to really define it and we can use it ready-made. Okay, before we jump into code, I generally like to do a couple of, thought points about what are the things to, kind of make sure or trip points, possible tripping points, and make sure we don't trip there. So for example, in this case, either of the lists could be pointing to null, indicating, they are empty lists. And we should be able to handle that without really adding special code if possible. That's always a good plan. So your code stays simple and you don't have to test for more test cases. The other thing I can think of is because you are building a new list, we kind of have to set the next pointer of the previous node. So we kind of have to stop at one node before in the result list. And we have to save the original head. So I think what we need to do is we need to do a result, but we need to allocate it to some dummy node. The value doesn't really matter, and the next pointer will be null for that. And the reason we do this is so that we can do result.next equals, and without worrying about whether result is pointing to something or not. Otherwise, we'll have one special case when we are, doing the first node. And we also need to, we shouldn't really move result around. A result will always point to that first dummy node. And so we'll just say cur node equal to result. We'll start, and cur node is the one that will update in the loop and keep on doing next, and so on, so that at the end of the loop, result still points to the first node and result.next is what we can return as the head. Hope that makes sense. Otherwise, watch the video again and make sure that makes sense. Okay, so now our logic is going to be pretty easy. We are saying, okay, how much do we need to run the loop? Well, we need to run the loop while there is something in list 1 or something in list 2, because then until then we have not merged everything. So let's say while list 1 is not equal to null or list 2 is not equal to null. Okay, now inside this, again, remember either of the lists could be null, but both cannot be null, because if both are null, then we wouldn't actually execute the loop at all, because both the OR conditions will become false, right? All we need to figure out is, okay, do we need to pick the node from list 1 or do we need to pick the node from list 2? And the logic is, if we pick the node from list 1, if list 2 is null, then it doesn't matter what the values are. Or list 2 is not null, but list 1's value is less or equal to list 2's value. So let's do that. So we say if list 2 equals null, or, and remember, here we will have kind of two conditions, because or list 1, we have to check list 1 is not null before checking that list 1 has a value, or before checking list 1's values. So dot val, is it dot val? Yes, it's dot val is less or equals list 2 dot val. And the reason we don't have to check list 2 is not null is because if list 2 was null, it wouldn't have executed this part of the whole condition. Because in Java, like many other programming languages, conditions are evaluated in a short-circuited fashion, which means if the whole Boolean expression, if the first half gives enough information for the whole thing, the second half or more halves than the second are never actually evaluated. In this case, if list 2 was null, it wouldn't even bother to look at everything else because it's an OR condition. So anyway, so these are our two conditions under which we are going to pick from list 1. So let's pick from list 1. Now, if we don't want to duplicate code, actually let me simplify that a bit later. So let's just write it down in a raw fashion. We say, okay, current node dot next. Remember, we have a dummy node always, which means current node cannot be null. So it's always safe to do dot next. Okay, current dot next equals list 1. Okay, whatever list 1 is pointing to, because we are picking from there, and list 1 equals list 1 dot next is, yes, list 1 dot next is the field that has the next pointer. Okay, and then here we say else we always pick from list 2. So here we have the same code, but we just are picking from list 2. And whichever list we are picking from is what we are moving forward. Here we move forward 2, here we move forward 1. And remember, those are guaranteed to be not null, because otherwise, if you evaluate all these Boolean conditions, you will know that this is guaranteed to be not null. Okay. Now remember, we haven't yet moved forward our cur node. Cur node dot next we set it, but now cur node should be equal to its next node, so that now when we pick the next node, it actually attaches at the end of the current node. I believe that should work, except we still have to figure out what to return. And remember what I told when I use this dummy node concept. I should actually, generally I would add a comment in real production code here is start with dummy node to avoid a special case. Okay, so here we would say return result dot next, because remember the first node is dummy, and only the one that it points to in its next value is the one that is actually the head of the list. That is, I think, pretty good. I would want to, before I run it, run through like one example. Maybe I always try to run through like a normal example, not an edge case first. So let's run through this 1, 2, 4 and 1, 3, 4. Although I don't like that the average case has duplicates in them, but doesn't matter. Okay, let's go through that. So list 1 is 1, 2, 4, list 2 is 1, 3, 4. So we come here, we have a dummy node. So remember, result is actually pointing to a node whose value is irrelevant, and whose next is null because of, I'm assuming the constructor here makes it null. Yeah, I think Java initializes everything to default values, so this one should be null. Okay. Now, so result is pointing to a dummy node, and remember, we never change what the result points to. I wish Java had a concept of constant, like in C++, you could make this like something like constant. It will make sure that it just by even accident, you don't change it. But anyway, So result is pointing to something dummy, and it will stay that way until the very end. And cur node is the one that we will use to loop through and build the list in result. Okay, list one is not null and list two is not null, but all it cares about is one of them is not null, and it is not. It's not pointing to null, that means. And then we say, okay, is list two null? That's not true, so it's going to evaluate this and condition because this became false, and it is looking for one of them to be true. List one is not null, that's true, and list one's value is equal to list two's value, and hence yes, 1 is equal to 1, so it's going to step in here and say cur node dot next is list 1, which means literally current node's next will be pointing to this node here, the red one, and then it will move forward list 1 to point to 2. Remember, we are not destroying the given list to us like list 1, which is not great because we are kind of pointing other lists to the same node, which is in real world dangerous, but for the programming problem it is fine. Anyway, now let's go to, well, in Java it's not dangerous actually, but still I think if you are editing the lists it's not very safe. Okay, now it won't evaluate else, it goes to cur node is cur node dot next, which means now in our result node, which actually is a 1, and there is a dummy here in the front of 1. Well, here they picked the blue one, but anyway, in our case we picked the red one, it doesn't matter. It will now point to 1 because of this statement. Keeps going. I think this should be fine, though all I want to do is I want to make sure at the end what happens. Okay, so let's say we picked the second one after that, because then this is pointing to 2, this is pointing to 1. Let's evaluate that case because that's the case it picks from the second list. Okay, so we moved forward here, not here. Both are not null. List 2 is null, that's not true. And even this is not true because now list 1's value is more than list 2's value, so it's going to pick on else. And this is the same as this, should work the same way, moves to next. Okay, I think that's good. So now we are at 2 and 3, and then we move forward, we'll pick 2, so we'll move forward here. 4 and 3, then this will move forward, then this will move forward, and list 1 will become null, and that is what I want to check, where list 1 has become null and list 2 still has 4 in it. So list 1 is null but list 2 is not, so it still goes in. Since list 2 is not null, it's going to evaluate this one, but here list 1 is null, so this becomes false. So it's going to go to else and pick from list 2, so it will pick 4, which is great, which is exactly what we want. Now both are null, so in this one it gets done and we return result on next. I think this should work. I don't know if there's a compiler or something like that, we'll see. Okay, looks like we were good. We don't have a compiler, and it is this test cases looks like have passed. It's accepted. Yep, cool. Hope that made sense. I can add a test case. I hope it is easy to add. Let's see. Yeah, let's add something with negatives in them. -10, you know, -2, 4, 7, and 13. And let's do here -15, -3, and let's have some duplicates, it doesn't matter, 8 and 100 and 200 just for the fun of it. Okay, and let's run again. Oh yeah, I don't want to do this. Okay, -100 and 100. Okay, so let's just not make this. Let's make this 10 and 100. Okay. It's interesting that it is doing validation checks on test cases that we are adding. Okay, I'm interested more in case 4. Yep, looks good. Yeah, there you go. I hope you enjoyed it. In real case, you would add more test cases and do some white box testing by evaluating the code branches and stuff like that, and make sure this becomes true, this becomes true, and stuff like that. For the video and keeping it brief, I think I'm going to end it there. Hope you enjoyed it. Bye bye.